Welcome back to the logarithms chapter. So we were looking into the formula sections of logarithm. So till now we have covered 5 to 6 of the main formulas, and we are just left with a small amount of formulas. So just to recap, number one, we have already seen that log of 1. So what was log of 1? So it was, if you take a b over here, so b to the power something equals to 1. So we can write it is always equals to 0, because something to the power 0 is always 1. So that is very clear. Number two was clearly if you have the same number as that of the base, bb, so then you will be getting a 1 over here. So that was always equal, because b to the power 1 is always equals to b. Okay, so then the third formula that we had was a product rule. So for example, ab, so log ab will be giving you log of a plus log of b. So this was already very simple. Then number fourth, you have a quotient rule. So what was that? Log a by b. So that was giving you nothing but log of a minus log of b. So whatever was in the denominator came in after a minus, and whatever was in the numerator came in after over here. Okay, so this is what we have studied. This was the basics. Then moving to the next one, we already had the fifth formula, which is known as nothing but the power rule. So log of a to the power m base b will be giving you m log of b a. So we can just take a multiplication. So as if we are bringing the power out as a scalar value, for example, over here. So if I want to give you an example, if I have 2 to the power 3 and base 3 over here, right? So we can take this 3 out from here. So we'll be giving you a 3, and we can write down everything as if nothing has changed. So log 2 base 3. So just bring the scalar the power over here outside of the log, and this is a multiplication. Okay, so this is 3 times log 2 3. So that is how you can find it, and 2 3 cannot be further simplified, so we can find out the value of this using your calculator. Okay, so this is base 3, this is 2, right? So this was simple. So this was the power rule. Okay. Then moving forward, we had change of bases. So what do we mean by that? So a b, so we can clearly write this is nothing but log a by log b. Okay, so and this was equal basis, whatever it is equal basis. So it can be z, p, q, whatever it is, it doesn't matter, 10, 5, 6, any value it can take, but both will be on the same basis. So if you want to change this b to c, for instance, so if I want to bring in log ac, so I want c in the denominator, so what will I do? I want log c in the denominator, so that is why I want this, so that is why I've written this over here, and I need to eliminate this, so I will write one more log b over here, because I want to eliminate this. So that is why if you want to get, like from here, if you want to bring in log ac, you need to multiply this value over here, which is nothing but log b base c. So basically if you want to get this, so this will be nothing but this, which is log ab times log of bc. So you can imagine this to be kind of a chain rule, log a base b. So whatever is in the base, you bring it in the top, in the operator zone, and you bring the base which you want to convert it. So this is the base, you can see, so bring it in the base zone. So that is how you get a change of bases. I hope it is very clear. So just to move forward, so going to the seventh formula of a logarithm. So what is the seventh formula of a logarithm? So you know, so till now we have formed bases. So that's not a formula, you can say, but if you take, for example, a to the power m, and base also has a b to the power n, for instance. Okay, so what happens to, okay, so before this, let me give you a quick trick. So log of ab, so right, we are looking into reciprocal theorem. So log of ab, we already saw that it was nothing but log a by log b. So this is already seen. So can we conclude from here, if we have log b base a, ba, so we are just like making the base as the value as the base. So what happens to this? Can we write that this is log b by log a? So can you see that these two are just reciprocal to each other? So from here we can conclude that log of a b will be nothing but 1 by log of b a. So this is very much conclusive from here, that log of a b is equals to 1 by log of b a, because this is nothing but the change of bases that we are doing over here. I hope this is very clear. Okay. So if I have a question like, log of 8 base 10. So can I write that this is equals to 1 by log of 10 base 8? Yes, of course. So why do we want to do that? So for instance, sometimes we are like communicating with respect to something called rupees. Okay, sometimes we're communicating with something called a dollar. So we need a conversion factor, right? So these bases are